Hello and welcome to this video on circles, ellipses and rose patterns. I want to get to drawing these rose patterns, but first I thought, how can I even draw a circle? I know PyAngelo's got the circle command, but if I didn't have the circle command, how would I do it? Now, the circle command that we use specifies the center of the circle, and then it specifies a radius. So say the radius is this long. Now, I know that the radius has to be the same at all points around the circle, but then how do I link these up with this curve? That's what seems difficult to me. With a rectangle, you've just got straight lines, and that seems to make sense. But here, we need this the same distance away everywhere we go. Now, if we have our regular Cartesian plane, we're used to specifying the coordinates in terms of the x and the y. But there's another way we can specify these using polar coordinates. And with polar coordinates, we specify a distance and an angle. So the distance could be this long here. Let's call that r for the moment. And then the angle is the angle here, and let's call that theta. Now, this is perfect because if we just take that radius and change the angle and keep going around, then what we're doing is creating a circle. So we do here and just extend this angle a bit further. Then we can just go from 0 degrees all the way around 360 degrees, and then we just create that circle. But how do we then actually plot this on a PyAngelo canvas? Because we need to specify an x and y coordinate. So we need to be able to convert from these polar coordinates, which have the angle and the distance, to our regular x and y coordinates. Now, fortunately, trigonometry is going to save us here. So say I have this point here, and I specify it via a distance and this angle. Now, I need to specify this point in terms of x and y. So normally I would figure out how far across I go. That is my x. And then how far up I go. That is my y. And I know that this is the distance, we'll call that r. So using some trigonometry and our good old SOHCAHTOA, we can figure out this x and y because the sine of an angle is the opposite over the hypotenuse. So if I do the sine of theta, that's equal to the opposite, which in this case is equal to our y, over our hypotenuse, which is the r, because this is our right angle triangle. And then similarly, the cos of theta is equal to our x over r, because x is the adjacent over hypotenuse. And using just a little bit of algebra, we can multiply both sides by r, and then we get y is equal to r times the sine of theta, and x is equal to r times cos theta. And that's how we translate our polar coordinates into x and y. And we do that for every angle around the circle. Let's give it a go, and we should be able to draw a circle. So I've created a sketch here. I've called it rose patterns, but we're going to draw a circle first up. So let's do that. I know I'm going to need to import some things from the math function. So from math, import the sine function, the cos function, and both of those work in radians. So I need a radians function to convert my degrees to radians. Let's set the canvas size. Let's just start with 400 by 400. Let's give it a background color of like a really dark gray. And then let's see how big we want our circle to be. Let's call it r. Let's make it equal to 200. And then let's go around the 360 degrees. So for angle in range, 360. So that'll be 0 to 359. And then let's just calculate the x and y. So x is equal to r times the cosine of our angle. But remember, this angle's in degrees. We need to convert it into radians. And then do the same for y. So y is equal to r times the sine of the angle in radians. And then we can just draw our point at x comma y, and we should be good. Let's test it out. Oh, here we go. Now, first of all, our circle is we've only drawn this top quarter of the circle, and it's hard to see against that background. So let's change the color. But we also, what I think I need to do is move the center of the circle to the center of the screen. So let's do that. So before we start drawing anything, let's translate to the width divided by 2 and the height divided by 2. And let's go a stroke color of 255, 0, 128. And let's try that again. Hey, there we go. Now that's looking good. But if we zoom right in, we can see that we're just creating little dots, not a whole shape. So let's make it a whole shape by using some Piangelo commands. We can say begin shape, and I'll do that right before we start going through the angles. And then instead of point, I say vertex, and it remembers each point. And then when I say end shape, it joins them all up. So here we go. There we go. And then we've got our black circle. And we could change that color just by setting the color. So I did the stroke. Maybe we could say fill, and we could make it the same color. And then it would fill it in there. There's our circle. Now, that makes me think, I've got a circle, but how would I get an ellipse? When we drew our circle, it had the same radius everywhere, but an ellipse is a bit different because it has a radius that is longer in one direction and shorter in another. So when we calculate the x here, we just need to use a different value for that radius than when we're calculating the y. So let me show you. Instead of just r, we could have x radius equals, and let's just make it a bit smaller, 150, and then the y radius we could say is equal to 100, and then when we calculate the x, we use the x radius, and when we calculate y, we use the y radius. And then, hello, we've got our ellipse. Now wouldn't it be cool if we could put this into a function and then we could just use it whenever we wanted? And that's essentially what Piangelo's done, but let's give it a go ourselves. So I go add a new file, let's call it shapes.py, and then I'm essentially going to copy a lot of this stuff. Let me just copy the whole lot first, paste it into here. So yeah, I definitely want to import the math function. I don't want to do the set canvas size. I'll do that in some normal spots. I don't want to set the background. I don't need the x radius and the y radius because what I want to do is define the function. So let's do that first. Define, and if I do ellipse, there's already an ellipse function. Let's call it myEllipse. myEllipse. And we're going to pass in an x and a y, which is the center of the ellipse, and an x radius and a y radius. And then we are going to translate not to the center of the screen, but to the center of the circle, which is what our x and y parameters are for. We don't need to set any colors. We'll let that do there. We want to do the rest of this though. Begin the shape, go through the angles, and then calculate a new x and a new y. I can reuse these variables because once I've translated, I don't need to store them. So I think I'm fine with x and y reusing them here. I think that should work. Let's try it. So in here, let's get rid of most of this. And we need to now, from shapes, import myEllipse. And then after drawing the background, we go ellipse. And let's put it at, let's go to the center of the screen, 200, 200. Let's make it let's make it 50 wide in the x direction and 100 wide in the y. All right, there we go. And again, we can just change the colors by setting the fill. So fill 255, 0, 128, for example. And there we go. All right, that's pretty cool. Now, these rose patterns are similar in a lot of ways, but the radius is constantly changing according to this cos function. And also, we're not just doing it according to the angle, we're also by this k. And if we look over here, we can see that k is determined by the numerator, which is this number across the top, and the denominator. So if you have a numerator of 3 and a denominator of 2, we get this shape here. Let's see if we can code up a function that does that. That sounds like fun. So let's go into shapes.py and let's create a new function. We'll keep our myEllipse function. Let's define one called rows. And for the rows, again, we need the center of the rows, so the x and y coordinates. We need a radius, how big ours is going to be. Let's just call that the radius. And then we also need this numerator and the denominator. All right. Now, the first thing we need to do is translate to the x and y. I think there might have been a little problem with our function that I created over here. Let's just test that out, actually. Did I make a mistake? I've created my ellipse here at 200, 200. And then what if I create another ellipse at let's make it 100, 100. Let's make it 200 wide and 200 high. So it should actually be a circle. I forgot the brackets. Okay, let's try that. It does look like it's working quite nicely. If I do it 100, 100 and make it 100, 100, yeah, that's working beautifully. I was worried about this translate because I thought that the translate would stay so that when I called the 100 it would translate it on, but it seems because it's in a function I don't have to change it. So if I did also an ellipse at 0, 400 and made it 100, 100, yeah, it looks like that's all working beautifully. Oh, hold on, I did ellipse, ellipse, ellipse. Oh, I'm calling the actual ellipse function. How silly. I should be calling the myEllipse. 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 So I was just using the built-in ellipse function. Let's see if this actually works. Okay, let's try it. Yes, but see now here's the problem. The first one drew and I wanted the next one to draw here, but it's moved it over because this translate function is cumulative. So what I need to do for this is I need to save the state and then I need to restore the state. And now if I run it, these ones, yes, now it's working correctly. So there was a bug. Firstly, I wonder if you noticed that I created this, imported the ellipse, and then I used the built-in ellipse function. Oh, silly. Crazy. Yeah, I hope you noticed that. And so this is why I needed the save state and the restore state, because the translate's cumulative, but this saves the state before it returns it, and then it'll be better. So, all right, I think we're good to go on with our rows one. So before I translate anything, I need to save the state, and then at the end, I need to be able to restore the state. Okay, and then we want to do the same thing. We want to begin the shape. We want to go through all of the angles. So for angle in range 360, we want to calculate the new radius because this radius is constantly changing in the rose patterns. That's how it works. So we're passing in a radius. Let's calculate the new radius. I'll just call that R. And that's going to be equal to, and then this is where we need to look at this here, A times cos k theta. So it's equal to the actual radius times the cos of k times the angle. But remember, this needs to be in radians. So we need to put this into radians. And we haven't specified what k is. And k is actually equal to the numerator divided by the denominator. And I think what we actually need to do is, because of the way these rose patterns work, is we need to do it the circle not just once, but times the denominator. So so we can get the pattern to finish off. And then we can calculate the x is equal to the radius times cos of the angle in radians. Y is equal to the r times the sine of the angle in radians. Then we can put the point in x comma y. Again, it's okay to reuse these x and y's. And then at the end, I end the shape. And we should be good. Let's give it a whirl. What are the chances that actually worked? I haven't actually done anything. I haven't actually called the rose pattern. So import myEllipse and rose. And then I don't need so many ellipses. Let's just go rose. And let's put it at 200, 200 in the center of the circle. Let's make the radius 200 as well. And 3, 2 and see what we get. Oh, we get an error. Oh, radians. Radians. Let's try again. Hey, look, there's our rose pattern. There's our rose pattern. Numerator 3 and 2. Looks good, but it's kind of filled in. I wonder if it would look better if we did a no fill. Let's try that. So over here, I want to make this the stroke, and then I want to say no fill. Hey, that looks good. Let's make the stroke weight a bit bigger. Stroke weight of like 4. Now this looks good. All right, now what I'm going to do is actually try all of these different ones. So these circles go from 1 to 7 and the denominator 1 to 9. Let's try that. So I can say here, for denominator D in range 1 to 10, so that'll go from 1 to 9 as it said. And then for numerator in range 1, 8, so it will go to 1 to 7. And then I call the rows, I'm going to put it at 200, 200, make it 200. And then in here, I'm going to pass in the numerator and the denominator. And then I'm going to sleep for 1 second so we can admire it. And then draw a new one again. So inside each loop, I want to actually call this background function again. So I can just do that. In here, draw the rows, sleep for 1 second. And let's also, after we've drawn the rows, let's display the numerator and denominator. So let's text the numerator plus a colon plus the denominator. And we need to turn these into strings. So the string. All right, let's see what we've got. Oh, text missing 2 required positional arguments. Oops. Okay, so what we need to do is specify 0, 0. Let's put it at the bottom left and let's make these 50 pixels in size, the text. All right, oh, but they're black. Oh, okay, yes. So, yes, I want to do fill 255, 0, 128, and then I need to put the no fill back before we draw the rows. Now we should be in business. Oh, alrighty, there we go. Look at those beautiful rose patterns. Oh, that's a nice one. All right, well, I hope you've enjoyed this. We've covered a lot of ground. We learned how to draw circles using polar coordinates, ellipses, and now we've made these fantastic rose patterns by changing the radius according to that cos function. Very cool. Have a go, see what you can create, see if you create something even better using these patterns, and let me know. Thanks so much for watching, and I'll see you in the next video.